All right, so our first speaker today is Navneet, and the title of his talk is A Physical Internet.
Good morning, everyone. So the talk of the day that I have for the 3 minutes is the physical internet. Now, many of us attribute the physical internet to something which is data-driven, which has a lot of data that goes around, and this data is requested by billions and billions of users. So it has ensured it gets to the final user. So the model that I'm going to be looking at is the internet and how data goes around, and how it gets to the final end customer that is sitting at the terminal. Now, this network is driven by fiber optic cables, which is in a sense where the data gets transmitted. So that's the backbone of the internet. Now, the analogous system that I'm proposing is the physical internet. In the physical internet, it is the physical internet in which products get moved around and they get to the customer the same way as in the regular internet. It's a multi-modal network. That means that there's multiple number of transport carriers, there's multiple number of transportation providers that touch the product to make the move happen. Now, in this, there's the physical transmission. As we saw in the internet, there's transmission of data. In this one, there's the physical movement of goods. Now, this is based on the work of Montreal, who's based in University of Laval, out of Quebec City in Canada. And I've been collaborating with him for the last 1 year. And so let me talk about what is the physical internet. The physical internet is being proposed by me is the 10 networks of today, the logistics network of today. They are very fragile. Anything can happen and they can break down at a moment's notice. The freight transport sector is a big polluter, and they've emit a lot of greenhouse gases. The system is inefficient in the sense that there's truckers that are carrying halfway to the US and then coming back empty. So there's a lot of empty miles that are being traveled, and also many of these truckers are going far away from their homes. So they are known as the cowboys of the interstate system because they go away for days on end and they never come back. So their lifestyle is really unhealthy, and there's the highest rate of obesity among truck drivers is close to 60 to 65%. That was quoted by a recent study. There's rising logistics costs. It is about 20 to 20% of GDP anywhere across the globe, depending on. It's about 10% in the US. If you go to developing economies like China, it's about 10 to 20%. And there's driver shortages. As I said, drivers are going with a lifestyle that is not conducive to going back to their homes. So more and more they're away from homes and they're spending a lot of time away. So they don't like the lifestyle and they kind of tend to stay away from this profession. So the model that I'm proposing is scalable in the sense it can grow pretty quickly. So if it's deployed at a small scale and it can be accommodated to grow at a pretty fast scale, it's a node to node versus what is now a hub and spoke. So if somebody has to get a product to New York, they probably have to go into Bangor instead of going direct from, let's say, a down east city like Ellsworth to Portland and then from there. So there's a lot of travel which is that is not needed, that is happening. So this network would be optimized for distance as well as travel time rather than in a hub and spoke model. It'll have standardized universal equipment and facilities. That means that products get packaged in standardized boxes and they will be distributed in a modular system, and this modular system will effectively and efficiently process the goods at terminal facilities, and then they'll quickly go out in a matter of seconds as they come in the door. This is self-correcting and resilient. What that means is that the system, whenever there's a breakdown or there's a congestion in one of the networks, then it'll stop going on that network and take an alternative like the internet does, if there's a data failure. Some broad goals of this physical internet initiative is that it's going to be environmentally sustainable. As we said, that there's a lot of empty miles that truckers are traveling. So this will eliminate the empty miles by making it much more efficient and driving less miles. It's going to be socially responsible in the sense that drivers would be driving short distances and not the long distances. So they go from Ellsworth to Portland, Maine, and then from Portland, Maine back to Ellsworth in a single day, and then go on their tour as they would before. It's cost effective because the product is getting handled a lot more times, but then the total time that is being devoted to travel is much less, and there's much less empty miles that are being traveled. The spatial connection to this project is, I'm in the process of the literature review for the physical internet and the different routing models, and coming out with a way. One of the leads that I have is compare the networks with using graph theory. So how do graphs propagate out, and how do graphs can answer the question of how do real transportation network that we have today work, and how does this proposed network will work, and if this is a better system than what we're using right now. The next thing that I'm going to do is model the physical network, the future physical network on a software solution. The software solution that I'm comfortable with right now is ArcGIS. I will be looking at other options to model the network as I go on and see if it's a much better network as compared to what we have right now. So that's my bibliography, and that's my talk. Thank you.
Okay. Thank you.